All right, so a company invests $800,000 in the short-term money market at a simple interest rate of... now, importantly with these, can you write down what you've got? A company invests $800,000, so write down that we've got $800,000. If you write the method marks and you write... if you write what you've got, you write a formula, you can still get marks for it even though the answer is incorrect. So, a rate of 12%, simple interest, how much interest is accumulated in 1 month. So, now, importantly, T, 1 month, is equal to, well, T is the number of years. So, simple interest in terms of years. So, it's actually 1/12 of a year, isn't it? So, we're just using the simple interest formula. I equals PRT over 100. And that is equal to, just put our numbers in there, 800,000 times the rate, which is 12, times 1/12 over 100. Now, that's going to be quite convenient because 12 times 1/12 is just going to be times 1. 800,000 divided by 100 is going to be what? $8,000. So we can work that out without a calculator, hopefully. And so that's how much you earn in a month. Now you could have worked out interest in a year. You could have done this where this is times 1, and then you would have had to divide it by 12 anyway. You could do that, but just to save yourself time, I've shown you my way. To buy his first car, Phil took out a personal loan for $15,000. So let's just write that out straight away. P is equal to $15,000. He paid it back over a period of 2 years. So let's say that T is equal to 2, and this cost him $2,250 in interest. Okay, at what simple interest rate was he charged? So if you do something like this, it's sort of showing me that you know what you're doing. If this is worth 2 marks, I might be able to give you a mark just doing that. And it also makes it more apparent about what formula to use when. First of all, it's simple interest. So I know that I've got I is equal to PRT over 100. And the interest calculated, let's just throw those numbers in. $2,250 is equal to 15,000 times R times 2 over 100. And what we've got to do, if you like, is I would give you a method mark if you got this incorrect, but if you actually showed me what you're doing in the calculator. We're solving this equation here, comma R. So I'm going to go ahead and do that, 2,250. So I'm going to menu 3, 1, and we're going to $2,250, oops, no, that's not it, is equal to, what was it, 15,000 times, we're finding R, aren't we? And what was it over 2 years, or how many years? Over 2 years. And that is all divided by 100. Next time I'd use the fractions thing, but this should work out okay, comma R. Did you get a rate of 7.5%? Yep. Good. Okay, so therefore we've got R is equal to 7.5%. That was the simple interest rate. Once again, if you write this, I'd expect you to write out what you're doing in your calculator, and that will be effectively your method mark. If John invests, so far so good hopefully. If John invests $20,000 at 8% per annum, then we want to have R is equal to 8, P is equal to 20,000, simple interest until he has 32,000. Now this is the important thing. Until he has 32,000 means that the interest accrued is equal to 32,000 subtract 20,000. And this is where some of the students were using the 32,000. If you know formulas, well and good, but you've got to understand the difference that the interest earned isn't 32,000, the interest that we've got to subtract away the principal amount. So that's $12,000. Okay? Now, $12,000, we know I, we know P, we know R. For how many years? We need to know T. So this time now you could go ahead, and we know that our formula is equal to IPRT over 100, and you can rearrange that formula, and you've even got that in your notes that I gave you. You could solve an equation and you don't have to rearrange. I'm going to probably do that. I'm going to just say solve, and I'm going to solve for I, which is 12,000, be careful, it's not 32,000, is equal to 20,000 was the principal, times the rate, which is 8, times t over 100, comma t. And if I put that into my calculator, so 12, 28, okay. So if I go menu 3, 1, solve 12,000 is equal to, and I'm going to do my little fractions button, I'm going to go 20,000 times 8% times t over 100, and we're going to do over here, comma t, and is that 7.5 years? Is that what you got? Yep, good. Okay, so therefore we can say that t is equal to 7.5 years. All right, hopefully, is there any questions so far about that? That's just a simple interest formula. All right, so over a period of 5 years, an investment earned $1,250 at a simple interest rate of 5%. What was the original amount deposited? I'm not going to bother with that. That's pretty straightforward. We've done enough of those. Let's move to question 5. Okay. How much money would be deposited in an account after 5 years if $3,000 is invested? So our principal amount is $3,000. It's compounded though, so we've got to be careful. When you see that word compounded, we're using the compound interest formula, which is what? Isn't it A is equal to P 1 plus, is it R over N over 100 to the power of what? T times N. So this time we know that it's compounded annually, so it changes once a year. So N is equal to 1 and T is equal to 5, isn't it? So you've got to work out A is equal to, let's do this in our calculators. We've got 3,000, 1 plus. We've got R over N, which is, what's the rate? It's at 10%. So 10 over 1, which is just 10 over 100. Now, you can leave, sometimes you get some ugly ones, and you can't simplify this fraction. And I'm going to show you, just in your calculator, to use the fractions button twice would be the best one. Now, 1 times 5 is 5 to the power of 5. So I'm doing that in the calculator. Now, I could simplify that as 10 over 100, which is just 0.1, but it doesn't always simplify, so let's have a go. I want to go for, we don't have to solve this time though. We've got 3,000 times bracket 1 plus, and go the fractions button, and then go the fractions button again. Gives me a fraction inside a fraction. So if you like, just for the time being, I'm going to just do it this way. 10 over 1, just to show you. And then that's over 100. And then that is to the power of, what was it, 5? Is that right? Yeah? Now, I get some answer, which I don't know why it's in that. You should get 4,830. What did you get?
I got the right answer, but I found 8. I didn't solve for 8.
Yeah, that's fine. That's fine. What did you get? What did you get, girls?
4,831.
Okay, so my calculator's doing some funny things. I'll go into that later.
0.53.
Yeah, that's all right. 0.53. Is that right? Okay. Compounded monthly, well, the same thing. And you just need to know that the only thing that's changed is that N equals 1 adjustment per year is now 12 adjustments. And, of course, T is still 5. So rather than this equation here, we've got 3,000, 1 plus, and this R is still the same. 10 over 1 becomes 10 over 12, and then that's all over 100, and it's times... we've got 60 payments or 60 adjustments in 5 years. 5 times 12 is 60. So we've got to put this one into our equation this time. So let's try this. I'm going to go over here though, and I'm going to press enter, and I'm going to copy that just to make my life a bit easier and just make a couple of small adjustments. I'm going to change that to, let's make that a 12. And let's make that a, what was that? 5 times 12 was 60. And I don't know why it's giving me these stupid, crazy... What was it? It was like 4,900 and what?
$5.93.
Is that right?
Yeah.
4,000. What was it, Luke?
4,000.
Yeah.
135.93.
135.
935.
935. Yep.
93 cents.
93 cents. Okay, can you see there that compounding monthly pays a little bit more, doesn't it? Can you see there that is more than that? So it actually makes a significant difference when it's compounded monthly. All right, I'm going to skip question 6 for the time being, but I am going to go through question 7. Phil wishes to invest $1,500 for 4 years. Which of the following is his best option?
Can you go through C, sir? Because I got the first 2 right.
Yep. I'm just going to pause this now. A lot of you haven't tried this. I'm going to give you a 5-minute breather to try this first, if you haven't already done so. If you have, I'd like to get you to try some of the other ones, such as question 8. Phil wishes to invest $1,500 for 4 years. What's his best option? Shh, thank you. Compounded annually. So 6%, so we've got to use the compound interest formula. So I've got A is equal to P1 plus R on N over 100 to the power of, what is it? N times T, isn't it? Okay, so we've got that one, which is equal to this. So you should have had this, and it's 1 plus... It's compounded annually, so it's 6 over 1 over 100, and it's how many years? 4 years? 4 years times 1. Now that was approximately equal to, what was it? $1,893 approximately. 72 cents. Okay, what about the 5% interest compounded monthly? It's the same thing, but this time that the N is equal to 12. So your formula should be equal to, it should be equal to this, and I'm not going to do it in my calculator, but 1 plus, we've got 6% over 12 months, so it's like 0.5% a month if you like, over 100, and this was, if it's compounded monthly, no. It's, 5%, my bad. Thank you. And this was what? It was 12 times 4, so that's to the power of 48, isn't it? Now, what was that approximately, Andrew? 1831 and 34. Good. Shh. So far option A is better, and 6.5% per annum. Now this is really interesting. A lot of students made this mistake, so make sure you take note of this if you are watching this video. I is equal to PRT over 100. But remember that this is just the interest earned. So 6.5% interest on $1,500 over 4 years at 6.5 over 100 was approximately, what was that, 390?
Yep.
Is equal to 390. Oops, 390. Now we need to add that onto the principal. So remember that the amount that you have, the amount is equal to 390 plus 1,500, which is equal to 1,890. So clearly the best option was option. You have to add it because all this is telling us is how much interest earned. You need to then add it to the principal amount invested. And that's the difference. The compound interest formula tells you the value of the investment. However, the simple interest doesn't. Not that I equals PRT on 100. No, it does not. Now, Sam buys a new home movie system. Cost is $14.50 and it's depreciated by 12% per year by the flat rate method. Calculate the annual depreciation of the equipment. I'm going to pause it there. I'm going to get the formula out. Away we go. So what we've got to do is, first of all, write out what we've got. The annual depreciation amount you should have is equal to PRT over 100. This is just, the flat rate is just like simple interest, if you like. But that's how much it's depreciating. So what you've got is that each year, T is equal to 1, principal is 14,500 at a rate at 12% times 1 over 100. And if I was to do that in my CAS, that's going to give me, what's that? Control. First of all, I'm going to change the settings on this thing. Document settings, degree, format, normal, calculation. Let's get this to approximate for the time being. All right, so let's go to what's that? 40. Oh, it's really small. Okay, 14,500 times 12 over 100. Oh, why is it doing that? What is it? 1,700. $1,740. Okay. So this is how much it's depreciating per year. Now this is like a linear depreciation because after 1 year it's going to be 14,500 subtract 1,740, and then the next year it's going to also subtract by 1,740. So that's the difference though between the second one. Now calculate the book value after 4 years. So the book value is equal to the principal minus depreciation, which is equal to my $14,500. And if you like, because it's a flat rate depreciation, then it's actually just 4 of those, isn't it? You could just do that. You can't do it with the other one. What's the other one? Variable. What's the other depreciation called? Reduce balance. Yes, you can't do with that one. So I'm going to do that, and your answer should be, I don't know why it's coming up with these stupid thingies. 4 times 1740. Oh, what did you get? 7,500. $7,540. Is that right? Good. Now, I'm going to pause this here and I'm going to get you to have a go at questions 9 and 10, please. Just for a sec if you haven't already done so. Okay, really quickly with this one. This is just plugging numbers into formulas, but you've got to get the right formula. The variable, or what is it called? The reducing balance means that it's reducing at a certain percentage. It's like compound interest. It's sort of in reverse though. It's actually depreciating at that amount. So first of all, we have to understand how the formula works. Well, the book value after T years is equal to the principal times 1 minus the rate over 100 to the power of T. This is after 5 years. Now, that is equal to, so if you put into your calculator that $40,000 depreciates 1 minus 17 over 100, you could have put that in if you realised 17 over 100 is 0.17 in decimal. That's what I've done in my calculator. And if you put that in, you should have got, that's right, a value of 15,756.20. $15,756.20. Now, this one's a little bit different because this time you've got to work out how much repayments are coming in, how much interest is supposed to be paid, taking that off what it's worth. Now, first of all, we've got to work out the amount of interest to be charged. This is, what type of interest is this? Is this just simple interest?
No.
I don't know. I'm going to pause it a second. I'm going to get you to think about it. All right, so just quickly, in this one there's no formula, but we are told that the bike was originally worth $1,750. So we've got that the principal is equal to $1,750. Now over here on the right hand side in green over here, I've worked out how much repayments. Now the repayments, you clearly pay the principal and you pay an interest. So the total repayments, you can take this to the bank, is equal to the principal plus the interest over the term. All right, so the interest earned isn't $2,870.50. I've worked out... You're now on YouTube with a mockingjay. $250 plus $61.25 for 30 months adds to $2,087.50. But that, of course, has to come into account with the total or how much the bicycle is worth. So if I subtract $2,000 or $1,750 from $2,087,
Where'd you get 2087 from?
30 payments of $61.25 plus $250 is $2,087. If I then subtract $1,750 from $2,087, that is going to give me how much interest was paid, $337.50. So the amount of interest charged is $337.50. And then once I have that, I can then use it in this formula, ladies and gentlemen. 337.5 is equal to 1750 times the rate, which we've got to work out. We don't know that yet. Times the time. 30 months is 2.5 years, over 100. And we're solving that with respect to R, aren't we? Now let's have a go at that. 337.50. Please, I don't want any more mockingjays. Menu 3.1. I want to solve, and I'm going to copy this 337.50 and I'm going to paste it into there. 337.50 is equal to my principal. What was it? 1750. 1750 times my time, or my rate, which we don't know, times by my time, which is 2.5 years, over 100, comma R, 7.71%. Is that what you got? Excellente. So the flat rate of interest was about 9%. No, wasn't it? Well, I don't see that being 9. 7.71 I got. All right, I'll check that out later. All right, I'm going to pause it there.